Wait, what? Headache time.
I really like drawing. I have a headache all weekend.
Oh. Back to this one. So 1/8. Inverse functions. Now you've used inverse properties before, so let me explain how you use inverse properties and then I'll jump into what it means to be an inverse function. If I give you an equation that says 3x plus 7 is equal to -2. What's the first step of solving this equation? Subtracting the 7, right?
Yes.
Now, when you subtract the 7 here, what are these two called?
Opposites.
Opposites, but also known as additive
Inverses.
inverses. Additive inverses. And additive inverses, when you add them together, give you a big old fat 0. So then you get 3x is equal to, oops, I forgot to do it to the other side. Subtract 7 over there. -9, right?
Right.
Okay. Now, if I take away the word divide, how do you solve for x?
Wait, so
If
what?
I take
Oh,
away
you would also multiply it by 1/3.
Multiply by 1/3. So if I multiply this side by 1/3 and I multiply this side by 1/3, I'm more interested in the left. What are these two called?
They're
Multiplicative
inverses.
inverses. Multiplicative. And I'm not writing out the whole word. Inverses. I don't even like saying that word. Multiplicative. So when you're solving equations, you're constantly using this idea of inverses, which is actually kind of a neat thing. All right, so let me give you another equation. 2 to the x is equal to 8.
Isn't that where you have to turn into
You
logarithm?
would do the x for logarithm.
What's a logarithm? I have no idea.
Absolutely not, Sam.
So, can you tell me what x is equal to?
X is equal to 3. I can tell
X
you
is
that.
equal to 3. Now, what algebraic steps did you perform to get to x is equal to 3?
I just
Like
knew it.
previous
I
knowledge.
just knew it.
Previous knowledge.
Yes.
But I don't know
Two
what the
times,
word
two times.
is. I
Do you
just
remember,
know
like,
that I
in
knew that 2 cubed was
6th or 7th grade, you had problems like this?
8. Yeah.
I have no
And you had to find out what the box is equal to, and it came from previous knowledge that you knew something plus 4 was equal to 5. Same process that you did over here.
No, it's not.
The
It has
problem
to-
with that process of just, guessing it,
Always wondering.
is if I change it to be this.
Something to that.
Anybody do some laws?
2 to the x is equal to 18. I don't know what a log is.
That is not. That,
Yes, you
that
do.
can't be
I do,
solved.
but I haven't taught it yet, so therefore I don't know what it is.
That can't be solved.
It cannot be solved algebraically yet. Cannot be solved algebraically yet. I can kind of approximate it. If x is equal to 3, then 2 to the x is equal to
4. 8.
8. If x is equal to 4, 2 to the x is equal to
16.
16. If x is equal to 5, 2 to the x is equal to?
32.
Now, 18 is between 16 and
So it's gonna
32.
be like 4.5.
So my answer is someplace between 4 and 5. It has a fancy theorem associated with it.
Fancy.
That if your solution is between these two, your answer is between these two. It's called the intermediate value theorem.
You're gonna need to know that.
If I write it down eventually one of these days, yes, you will. But it pretty much says that if you have these two bounded on the y, then the answer has to be bounded between the x's.
What does that mean?
Intermediate value theorem. Intermediate value theorem. There's many versions of it. Proves a ton of stuff in calculus. So what we want to do is we want to come up with a way of, well, removing this idea over here.
Just erase it.
Yeah, I wish. So if I say, well, let f of x equal 2 to the x. If I just let f of x equal 2 to the x. I want to come up with this idea of an inverse function to kind of get rid of it. And the way we're going to notate inverse is Do I want to go this route yet?
Yes.
Please, Ned.
Yes, please.
Ned,
Not yet.
no.
I'll come back to that problem in a second. So let me discuss what an inverse function is and some of the properties we need. Property number one. Actually, property that we need, period. This idea called one-to-one function. And I'll explain why we need it right now. For instance, if I give you a function that looks like this, -1, 4, 2, 3, and 5, 4. Is this a function?
Yes.
Indeed.
Ned.
Indeed, because for every x there's exactly one
Y.
y. All an inverse function is going to do is going to take the x and y values and literally flip them. Their domain becomes your range becomes your
So it's not-
domain. So the way I'm going to denote this is it's still going to be called frank. I'm going to put this little -1 there. That is not raised to the -1 power, because frank raised to the -1 power makes no sense at all. This is just read f's inverse, or the inverse of f, depending on which order you want to go. So if this is going to work, all I have to do is take the coordinates and switch them around. It undoes what was done. In other words, if f takes -1 to 4, f inverse brings 4 back to -1. So it kind of just does a loop and brings you back to where you began. Problem though, what's wrong with f inverse?
It's not a
Not a
function.
function.
It's not a function anymore
That's not.
because we have this domain value, this 4, repeating. So this one is not a function. So we have a choice. How can I make it a function?
Get rid of those.
Inverse.
Not, do I have to get rid of both of them?
Only
Yeah,
one.
just
I just get rid of one. So if I got rid of that, that would be a perfectly fine inverse function.
Yeah.
If I got rid of this one, it would be a perfectly fine inverse function.
But do you
It
have-
loses some of its features.
But do you have to get rid of it on the top as well, in the original?
Yeah. You'd have to restrict your domain in the original one, and therefore restrict your range in your second one, if that makes any sense. We'll get to that later.
Flips.
So this idea right here comes in very handy.
And he needs what?
This f is not 1-to-1, because when I flip it over, it becomes not a function. And the reason it becomes not a function is because the x values are repeating, therefore it's breaking the axiom of for every domain there's exactly one range. But it's flipped, so therefore it becomes for every range there's exactly one domain. So when you say 1-to-1 function, what I'm really saying is markers dying. Great.
But those are expensive too.
Right.
For
I like
every
things.
domain,
There's one line around
there is a unique range. So it's almost the exact same definition of a function. The definition of a function is for every domain there is one range. But this one says it is
Unique.
unique. Unique means once you use it up,
It's gone.
it's gone. You can't touch it ever again. So once there's a 5-foot person in the room, there cannot be another 5-foot person in the room
Oh, darn.
because you cannot repeat itself. So a formula for this, or a algebraic expression is, given f of A is equal to f of B, then f is 1-to-1 only if A has to equal B. If we're talking about a 1-to-1 function, and I say I have these two y values that are exactly the same, that means the x values also have to be exactly the same. Otherwise, we're breaking what it means to be 1-to-1. So this property is how this one is solved algebraically. You write 8 as 2 to the third. 2 to the x is a 1-to-1 property. So you can pretty much ignore the 2's and you get x equals 3.
Something.
If the y values are equal to each other, the x values also have to be
Equal to each other.
So therefore x equals 3. It's kind of a neat property.
Wait, okay, I was writing when you were explaining
Oh,
it.
all right. Let me write it down over here.
Okay.
Your black ball.
Let me write it down. new page. So if I have 2 to the x is equal to 16. 2 to the x is equal to 16. To solve it algebraically, you write both sides as a power of 2. This side becomes 2 to the 4th. Now, 2 to the x later we'll learn is a one-to-one function. So if 2 to the x is a y value is equal to 2 to the 4th, which is also a y value, then you get rid of the function parts and just deal with the domains. Well, the domains are x and 4. So by the one-to-one property, x equals 4. I'm not canceling the 2's. I'm just ignoring them in a weird way. It's just, I'm using that property. If the y values are equal, therefore so are the x's. It's kind of a neat property. All right, now if we have a one-to-one function, we should be able to find its inverse.
Sure.
Maybe.
So find inverse of a one-to-one function. Well, the problem is I'm not going to tell you if it's one-to-one. So you're going to have to
Figure it out.
figure it out. And to figure it out, you
Yeah.
use this property over here, strictly, using a's and b's and everything.
Ignore numbers.
So if I give you g of x is equal to 2x cubed plus 4, the first thing I need to do is prove that it's one-to-one. So, step 1. Prove one-to-one. Now, if I'm going to prove it one-to-one, I'm going to make an assumption. I'm going to assume that g of a is equal to g of b, right off the bat. And this is the trick question of the day. What the heck is g of a equal? G of a, just g of a.
Definitely 3.
2 what?
2x cubed
Close, no cigar.
plus 4.
No.
X
3 x cubed.
2.
x cubed.
If I said, what's g of 2 equal to, what do?
You plug it in.
Thank you. G of a is equal to
G of a.
cubed.
It's equal to a.
2.
Y.
A
Cubed.
cubed
Plus 4.
plus 4.
I
Wow.
said that.
It's like pulling teeth. It's like pulling teeth. I don't know what it is about people's brains. They
Wait,
don't see
why
that.
did you?
Because this says take g and evaluate it at a. So you take a, you plug it in for x. Okay, this side. Ready? Let's see if it goes quicker. G of b.
2b cubed.
2b cubed
Plus
Oh
4.
my
plus
God.
4. Wow.
No, there's not equal.
Amazing.
Light bulb went on.
Yes, they are. Now, once you get to this line, you pretty much solve for one of the variables, but I usually choose a. So how do you solve for a? You subtract both sides by 4, and you get 2a cubed equals 2b cubed.
Divide by 2.
Divide by 2, you get a cubed equals b cubed.
And now you do the cube root.
The cube root of both sides, and you get a equals.
B. Wait, no.
Oh.
B equals B.
Is it plus or minus b, or is it just b?
No, it's just B because
It's just
it's
because
A.
it's a cube.
It's just a cube root, right? So, because I started off with g of a is equal to g of b, and I discovered that a has to equal b, then this function must be
1-to-1.
1-to-1. 1-to-1, check. All right, now we can go and find its inverse. To find an inverse, there's a few steps. Once it's a one-to-one function, it's guaranteed to have an inverse. It's also known as invertible. G is an invertible function. So here are the steps. Number 1, change g of x in this case into y. We want to go back to xy notation. 2, flip replace x's with y and y with x. There's only going to be one instance of y, that becomes x. Wherever there's an x, you're going to replace it with a bunch of y's. At this point, you are not talking about the original function. This is, well, the original function, and this will be its inverse. Once you take that x and y and flip them, you're automatically talking about the inverse function. It's just not in a form that we like. Step 3 is probably the hardest part. Solve for this new y. This y has nothing to do with the original y. And step 4, most people forget. In this case, g's inverse. G's inverse. Alright, so you get it out of function notation. You flip your x's and y's. You solve for the new y. This new y is called g inverse of x. Okay. So g of x is equal to that mess over there, right? So we have g of x is equal to 2x cubed plus 4, definitely a one-to-one function. So step number 1 says,
Change it from y.
change g of x into y, so you go y equals 2x cubed plus 4. At this moment, we're still talking about g of x. The next step, I'm going to separate it with a line. You replace the y with x, and you replace the x with y. We are now not talking about g of x anymore. This is literally g's inverse. In this form, it is really g's inverse. It just isn't looking nicely.
All right.
So, solve for y is the third step.
Okay.
I'm waiting for you.
I'm waiting for you to solve for y.
Okay,
If I solve for y, what do I get rid of first?
X minus 4.
So you get x minus 4 is equal to 2y cubed. Divide everything by 2, and you get y cubed is equal to x minus 4 divided by 2.
Now you have to cube root it.
And you cube root it, and you get y is equal to the cube root of x minus 4 all over 2. Now that's only step 3. There's still step 4, which says we're not talking about the same y that we started with. This y really represents
The inverse of g.
the inverse of g. So g with that negative 1, x is equal to the cube root of x minus 4 over 2. Ta-da!
Put it down.
These aren't that bad.
Oh yeah.
So let me ask you a silly question.
Can you
Off to the side.
homework?
What about it?
So many, takes a bit longer.
Oh, you want more?
No.
Less?
Yeah.
Shh.
You need to drink.
We'll see.
About
We'll
an
see.
hour.
If it took you an hour and a half to do that homework last night, I'm worried.
No, it didn't, but there was one night where it took
Yeah, I know. There was one. There's another night it took you maybe 10 minutes.
No.
For you.
It
No,
didn't.
it usually takes me about 5.
It
Excuse
never
me.
takes me.
When you take a test, it takes you an hour and a half. When I take your test, it takes me 10 minutes.
That's probably
You're
you
losing
got the
both.
answer key.
Actually, I could do that, but no, I usually don't. So, what if I want to find g of negative 2? G of negative 2. So I'm going back to my g function over here. If I plug in negative 2, you get 2 times negative 2 all to the third power plus 4.
And you do the no, you do the exponents first.
Well, I know, that's negative 8 times 2 is negative 16 plus 4 is
Negative 12.
negative 12. Alright? Now if I do g inverse of negative 12, what do you think the answer is going to be?
It's gonna be
Oh, it's
something.
1 over
It's gonna be
Nope.
negative 2.
It's going to be negative 2.
Oh, yeah.
Because that's where I started.
Yeah.
I started at negative 2, I ended at negative 12. If I start at negative 12 in the inverse, I better end up at negative 2. So the cube root of negative 12 minus 4 divided by 2,
That would be the cube root of negative 8.
which is the cube root of negative 8. So g inverse of negative 12 is
Negative 2.
negative 2. It's a neat property. It undoes what was done.
Just done.
Did.
English.
English. Ah, this razor stinks now. Alright. So, property of inverses. One of the main properties of inverses. F composed with F inverse of x is equal to, take a guess.
F.
X.
F is not a number.
X.
F is Frank.
X.
Or George.
X.
F inverse takes x someplace, let's call it y.
Y. And then
F takes y and brings you back to
X.
x. So this one has to equal x. And F inverse of f of x is also equal to
Something.
Y.
Why?
X.
x.
What they say.
Pretty much what is going on here is kind of like that +7, -7 canceling out, and the 1/3 and the 3 canceling out. You can kind of think of f and f inverse as
Canceling out.
Brothers.
kind of canceling out. Now there's some weird situations where they don't exactly perfectly cancel out. There's a possibility that f inverse of 2 is equal to 1. There is a possibility that it is not exactly equal to the number on the inside. But that's when we have to adjust domains. We're not doing that yet. So my next question is this. Is g of x equal to the square root of x an inverse of f of x equals x squared?
What?
Is. If. Is g of x equal to the square root of x an inverse of f of x equals x squared?
Hold up.
Okay, go do the steps, bro.
Which one?
Yeah.
Yeah? I say no.
But you're probably right because it's no.
Well, if I do f
Nothing.
composed with g of x, if I do f composed with g of x, my answer better come out to be x if it's an inverse. So this becomes g goes on the inside, f goes on the outside. F is something squared.
The square root of x.
Alright, and in the inside you put in the square root of x. So if you take the square root of x and you square it, you get
X.
x.
So it's an x.
Great. But if I do g composed with f of x, this is the square root function. What goes on the inside? X squared. And the square root of x squared is equal to?
X. No, plus or
Closer?
minus.
No.
Plus or minus
The
x.
absolute value.
Thank you. Absolute value of x. Because it's not strictly equal to x, these are not inverse functions. Unless you reduce the case to one possibility. When can you drop the absolute values? If x is positive. So if I force x to be greater than or equal to 0, then they are inverse functions. But they are not inverse functions over the entire domain. Why? You know what the graph of x squared looks like, right?
Yeah.
Is it 1 to 1?
No.
How can I tell if it's not 1 to 1 just by looking at it?
Because if you do the other
The other line, because
The other
you flip it
line,
around, you go
yeah.
horizontal instead of vertical. It passes the vertical line test, but it fails miserably
horizontal
the horizontal line test. So there is another way of thinking of 1 to 1. It's called the horizontal line test. Has to hit exactly once. So if I ask you if a function is a inverse of another function, don't just compose it one way. You have to compose it both ways to prove it is absolutely true.
So like if you have the this with like the square root of x squared,
Uh-huh.
we just say
Yes.
it's a function when x squared is 0.
I'm going to ask you specifically about some of those, though, so be careful.
So is
I'm
it-
not going to ask you that. I'll just say, are they inverses? In this case, no, they're not.
That's not? Okay.
They're not unless you let x be positive.
Okay.
Unless you let x be positive. And then that becomes a restricted domain, which is totally different. How about this? Find if f of x equals 3x squared minus 1 is 1 to 1.
What are we finding? Find if f is.
Find if f of x equals that mess is 1 to 1.
3 steps, 4 steps.
Oh, goodness.
And find inverse. And this one's a little bit not perfect. Find the inverse, but it might not be perfect. Okay, step number 1, defining out if it's 1 to 1.
You do
The
the
f of x 1.
So
you solve for a the ab.
you go f of
A
A is
equals
equal
f of
to
B.
f of b. Let's see if we go through this faster.
Maybe.
What's f of A equal to?
3x
3x
squared minus 1.
Yeah.
Okay, now you got the trick.
3.
3a squared minus 1, f of b,
3b squared minus
3b squared minus 1.
Mhm.
And you pretty much assume you're solving for A. So if you solve for A, what happens to the 1s? Cancel out. What happens to the 3s?
They cancel.
So you get a squared is equal to b squared.
Which equals a to b, which means that
Is equal to B.
a.
A is
Yeah.
equal to B.
A is equals b.
Write it out.
Come back over here. What's the square root of x squared equal to?
Absolute.
Oh, you tricked
When
me.
you square root both sides of an equation,
It would
what do you have to tag in right away?
Plus or minus.
Plus or minus. So if I square root both of these, I get a is equal to plus or minus b.
But it has to be plus or minus a too, right?
No,
Why not?
because how do you describe this?
It's both sides.
If you have a plus or minus on both sides, then you get actually 4 possibilities. They're both positive. First one's positive, the second one's negative. The first one's negative, the second one's negative. First one's negative, the second one's positive. But by all those combinations, a is either equal to plus or minus b.
Well, B is equal to plus.
No, no.
Okay.
Stop
You're
it.
confusing us.
You get 2 equations, which is a equals b and a equals negative b. That's the only 2 possibilities.
Wow.
No matter what a is or what b is, that's the only 2 possibilities. They're either the same sign or they're opposite signs. That's the only possibilities between any 2 numbers. Okay. So, this one would be perfectly fine for 1-to-1. This one is not good. So is this 1-to-1? No. Not
Don't have to do it.
1-to-1. When will it be 1-to-1? Then we get into fun stuff. So before I find an inverse function of this, let's graph it. How do you graph 3x squared minus 1? Sketch.
You make a graph.
Where does it go?
It goes like that.
It goes down
And then
one.
it
Goes down 1,
It goes closer to the.
and it gets closer to the vertical. So you get some graph that looks like this. I'm not drawing it perfectly, but that's generally what it looks like.
Sure.
What's that?
What?
The headache you're talking about. What is the domain of this graph?
Negative
Okay.
Negative infinity to positive infinity. What's the range of this graph?
Negative infinity to
Negative 1 to positive infinity. Alright, if we're going to do an inverse, the domain and range have to flip. The problem with this is it's not a 1-to-1 function, so I have a choice. I can take the left-hand branch and erase it. Do it.
You could
Because
take
it's
what?
low, negative 1, and it goes off to...
It's gonna turn on its side.
Or I can erase this half.
Or you could do
Do
that.
whatever you want to do.
I get to do whatever I want to do. So I'm going to choose. I'm going to choose
Not to do it.
x to be less than or equal to 0. Now, if I choose x to be less than or equal to 0, that changes the domain into negative infinity to 0. That would be our new domain, or restricted domain. Okay. Now, once I do that, I'm only talking about this part of the graph, the green part. And I want the inverse just for the green part. Okay. Let me get rid of this marker.
$20 down the range.
I didn't realize that's how it worked.
What?
Yeah,
No, you just click that.
that's how it worked.
Okay, so we go through our steps, and we're going to go y equals 3x squared minus 1. Okay. And replace the f of x with y. Second step,
Oh, we subtract. We add.
take the x's and y's and flip them. So you get x equals 3y squared minus 1.
Add the 1 over.
Solve for y, add 1 and divide by
3.
3. So you get y squared is equal to x plus 1 all divided by 3.
Now square root is.
Now square root it. Now, y equals the square root of x plus 1 over 3. Except for one problem.
Plus or minus.
Plus or minus.
Oh.
But now we get to choose. Is it going to be plus or is it going to be minus? Now remember,
Have you
our
positive?
domain and range are going to be flip-flopping.
I'm gonna say plus.
And if I choose x to be from 0 to negative infinity
It's gonna be
originally,
minus.
then y also has to be 0 to
It's gonna be minus.
negative infinity. So the domain here is,
Negative.
0.
no. The domain of my inverse
Oh.
function.
Negative 1 to infinity.
Negative 1 to infinity. Why is it negative 1 to infinity?
Because it flipped with the range of the
It was the range of the original function. It becomes the domain in the new one.
Okay.
The range here is my restricted domain. It's negative infinity to 0. So instead of saying plus or minus, I can say strictly minus.
Ooh.
So that becomes f inverse of x is equal to negative square root of x plus 1 over 3 for x greater than or equal to negative 1.
Oh,
Time to go yet?
Is it time to go yet?
like, I don't even know what the answer to that question is. I don't even know what we
Okay.
just did.
We started with this thing.
I'm not.
It's a valid question. We started with this weird function. It's not that weird, really. We proved that it was not 1-to-1. But I still would like to find an inverse for a part of it. So then I said, well, here's the graph of it. And it's not 1-to-1 because it fails the horizontal line test multiple times. So if I erase part of it, change my domain a little bit and say, well, let's start my domain at 0 and go off to negative infinity, I'd have half a parabola to work with.
Okay.
So if I have half a parabola to work with, it passes the horizontal line test perfectly fine. So I should be able to find this 1-to-1.
Yeah.
But before I do that, because I'm being funny with the domain, you start with the domain in range of the original function. You restrict your domain to be less than 0 because I said I only want to deal with half of it. And with this new domain, it becomes the inverse's range. So I just went through the process of changing it into an inverse and choosing negative because my range has
So
to
it
be
could have been
negative.
positive too.
Huh?
So it could
We could have done the positive side, then this wouldn't be minus, this would be plus. Because you have a choice, plus or minus.
Either way, we would have got it wrong unless we did the step wrong.
What if I was having a positive plus?
So what do you
What
want?
if what?
Still
If I
so.
had it as positive, would it be wrong?
I'd take off a point or so. I always grade my questions 5 points apiece. So then I just start reducing by off of the 5. There is partial credit, that's a good thing against multiple choice where it's either right or wrong, and I hate that idea. Because you can make silly mistakes.
Wait, so what's the answer to that question?
The answer is, the function is not 1-to-1, but if I restrict the domain, then I have this inverse.
Then,
So you
then
have to
is
tell
it
us.
1-to-1?
So we have to
Yeah, once I restrict the domain, it's 1-to-1.
So the answer is both yes and no to the thing.
Now it's 1-to-1.
So well, I'm confused.
What are you confused about?
Do we have
Why is it?
Oh, let me just do another one.
No,
Hold
no,
on.
No, do
It's
yourself
All
no.
I know is that box
It's okay.
square.
All I want to know is what do you want us to write down for the answer? Like not 1-to-1, but 1-to-1.
It's not 1-to-1. I want you to restrict the. I'll either A, give you the restriction, or B, you can either choose one or the other. Probably I'll give it to you. And then find the inverse, but make sure you choose the right inverse sign.
Oh, okay.
I don't know.
Inverse. Inverse sign, no, not inverse
Follow me.
sign.
How do you choose
What's that?
By the domain.
Quiz time.
If your domain is going to the left, you want to choose negative. If your domain is going to the right, you choose positive. Is it quiz time?
No.
Yes, it is.
Not even close. So, one more, just for fun.
One.
Yay.
What fun.
What do you? Is this the same question as the other one?
Is this graph 1-to-1 without even doing any math?
No.
Because it is a parabola, and parabolas wrap in on themselves. So not 1-to-1, guaranteed.
Alright.
Now, let's graph it.
Aw.
Oh, come on, it's on the test anyways. So if I graph this thing, where does it go?
Left 2 up
Left
4.
2, up 4, 1, 2, 3,
Oh yeah,
4.
it flips over. It flips over the x-axis.
And it flips over the x-axis, so you get something that looks like that. Now, I want to choose, I get to choose the left-hand side of this, because I like working with the left, because it makes it negative.
Why?
You'll see in a second.
Negative.
So, I'm a very negative person. I want to choose this side of the graph to make it a 1-to-1 function. So basically what I'm looking at is this point here and half a parabola. Now if I'm looking at that point there and half the parabola, what is the domain of this thing?
Negative infinity to negative 2.
Negative infinity to negative 2. What's the range of this thing?
Negative infinity to 4.
Negative infinity to 4. Negative infinity to negative 2. Negative infinity to positive 4.
Which one to be your new domain, your range?
This is my new domain. This is my range one way or the
Sound like
other.
another one.
Yeah. The green one is what I'm going to do the inverse of. Alright, so if I do the inverse of this function over here, the first step I do is exactly the same. Change g of x into y. And get that. Take the x's and the y's and flip them. So you get x is equal to 4 minus y plus 2 all squared. Solve for y. What would be your first step?
The 4 of them.
Most people would subtract the 4. What would be my first step?
To do the square
Flip them or
root.
something.
I would flip them, literally. I would take these two pieces and interchange them.
Why?
This one's negative on this side, so if I move it over here, it becomes
Positive.
positive. This one's positive on this side. If I move it over here, it becomes negative.
But does
So,
that mean that you have to move the entire y
Nope.
to square?
yeah, you have to move the whole chunk. But it makes it a lot easier because it gets it positive quicker. And it gets everything else on the other side to begin with. Alright, so move the y plus 2 all squared over to this side, it becomes positive. Move the x to the other side, it becomes negative. You get this thing. It's a neat trick where you can flip those two and not change any signs. How do I solve for y? Square root. So this becomes y plus 2 is equal to, I have to write it for now, plus or minus the square root of 4 minus x. There's a reason I have to write it for now. We'll fix it later on. Then finally,
We subtract 2.
subtract 2. So I get y is equal to negative 2 plus or minus the square root of 4 minus x.
Sounds like a.
Now, the domain of this graph, the domain of this function, is the range of this thing up here. So the domain of this thing is
Negative infinity to 4.
negative infinity to 4. We want the range to be negative infinity to negative 2. You have to take the domain and range and switch them. Now. Okay, digestion. Yeah. Lunch.
Once you, if you sleep during class, you actually remember things better.
Okay, now we can.
What?
What?
If you sleep
You
after
be
you
quiet
learn,
back
if-
there. Jeez, osmosis going on. Now,
Osmosis is-
if I choose numbers that are less than 4, I want to make sure that all my numbers become less than negative 2, all my answers. So probably something smaller than 4 that we could work with that's nice is 0. Square root of 4 is 2. To make this less than negative 2, do I choose the positive or do I choose the negative?
You said negative.
You take the negative. So,
Or you can take the positive.
if you take the positive, it gets bigger.
What? But
If you
oh, wait,
choose
never mind,
something
never mind.
smaller than 4, I chose 0.
Never mind.
This becomes 2. To make it smaller, I better choose negative. So I'm going to write this as g inverse of x is equal to negative 2 minus the square root of 4 minus x.
Okay.
Now, next question. How do you graph this one?
Absolutely no
I
idea.
got a copy.
You just
Which
like
way does
how
it-
you said that. You just
which way does it go?
flip to the side or something like that.
Goes
It's a square root, so it's gonna go like
4 to the
that. 4 to the
4 to the
left,
right.
right?
To the right.
Right.
Because when x is equal to 4,
Right.
this thing is 0, so it goes 4 to the right. It's that
So
weird
why
one.
ask?
So it goes 4 to the right, 1, 2, 3, 4,
It flips us
and
down to.
down 2. I'm going to put my dotted lines in here. And it starts here. And which way does it go?
It goes the
That
y.
This way?
Yeah.
No.
This way.
That way.
Yes.
Because it's, yeah,
Flipped
it's
over the
done.
X and Y.
Right. And this would be the inverse function of this green graph over here.
Indeed.
And then we'll talk about how to graph an inverse function from a graph later.
Okay.
Won't do that today.
I think so, because I was on the road to Greenville.
So if I have a function that looks something like this, let's do a 3 dot one. And this is f of x. Yeah, make it 4 dots.
Do we have to do this today?
Is there any points?
I'll give you coordinates for them.
Graph of f of x?
That's the graph of f of x. So maybe negative 6, negative 3.
Negative 4.
Yeah,
Well,
there's
that's 3
four.
down, that'd probably be
4, 5.
negative 4, 5.
Yeah.
Sounds good. This
That
one?
would be 6.
6.
6.
6, 6. Okay.
6.5.
6.5.
And then
Make that just 7. Make it a whole number.
Okay.
7. 8. Okay. Now, if you're just graphing an inverse function given a graph, I highly suggest you at least find 3 points on it. I don't care what the graph is. Make up the points if you have to, if it doesn't show any coordinate system. So just generalize, like we did with these, general coordinates, and then the trick will work. And the only thing you need to do to graph the inverse function is take each one of these coordinates and flip them. The domain becomes a range becomes a domain. So negative 6, 3 becomes negative 3, negative 6, someplace down here. Negative 3, negative 6. Negative 4, 5 becomes 5, negative 4, someplace over here. It's not going to be perfect, but oh well. 6, 6 is going to go.
6, 6.
It's going to stay right there. And then 7, 8 becomes 8, 7, someplace over here. So you get a graph that looks like this.
And that's its inverse?
And that would be the inverse function. So this picture, the blue part, is f inverse of x. This comes in handy when we do inverses of strange restricted functions, and we want to be really careful with the domain and range of it. All the concept of just switching the domain and range comes into play. Now, I love this one on a test because I'll ask something silly like this. And I'll have this graph. And I'll say, find me the inverse of this graph. So this is f of x. So the best thing to do is to come up with reasonable coordinates. First off, what would be a reasonable coordinate of our asymptote here? This is called a vertical asymptote. The graph is never ever going to cross it. X equals negative 2? Okay. So if we let that be x equals negative 2, if we find its inverse, this is going to get flipped also. So instead of x equals negative 2, my inverse is going to have
Y equals negative 2?
y equals negative 2. So you get this dotted line down here.
And that's the horizontal.
And it turns into a horizontal asymptote that you do not cross. Asymptote. Asymptote. Potato. Then come up with some reasonable coordinates. This would be a good one.
0, 1. Or
Negative 1, 0.
Negative 1, 0? Yeah, that works. Maybe up here?
Some, 5, 7.
5, 7? Sure. Doesn't have to be perfect, as long as you get the general idea of what shape is coming out of this. Alright, so we flip negative 1, 0, and that becomes?
0, negative 1.
Which is right about here. And we flip 5, 7, and that becomes?
7, 5.
7, 5, which is over here. And the other thing you have to worry about is this. There's a line going right down the middle of this graph. And
So
what
that's-
happens is the graph reflects over that line. So what was pointing this way turns around and points
That way.
opposite. So this concavity is going to get flipped around. So our line is going to be approaching this thing as it goes to negative. So it's going to be coming along here. It's got to hit this point. And it has to hit this point. Then it goes up. So the black one would be f inverse of x. So that's the best way to deal with it. Treat them as if there's asymptotes in there, the asymptotes go from vertical to horizontal, and you stay pretty much on the same side of them. Where this one stayed on the positive x side, this one's going to stay on the positive y side, and so forth and so on. So that's how you graph an inverse function. That's the end of inverses, I think. Well, actually, one small little piece.
You think?
Just a small piece. I kind of started it yesterday, but I never finished it.
What is it?
It's this idea. If I have some function evaluated at x is equal to 17, how do you solve for x? Oh, I have to give you a hint. And